Assalamualaikum. This is my second video lecture on machine design 1. Yesterday I have explained this summary of the chapter 8 of machine design 1, Shigley, book of Shigley. Today I will be solving problems in one video. In the second video I will explain briefly about shear stresses in bolts, and in the third video I will be explaining eccentric loading. So starting with the first problem, this is example 8.4 from the book. So I will be explaining the problem, and you can just open your book and check the problem, check the comments. This will be very easy for you to understand the problem. In this problem, in this example, they have written that a figure 8.9, which is shown here in this figure, a cross section of grade 825 cast iron, that is the material of the members. A total of n bolts are to be used to resist separating force of 36 kip. So we have X total force, but we don't have number of bolt. But we know that from the equation that total force on one bolt is total force experience, which is 36, divided by number of volt, which will be n. So single bolt force is 36 divided by n, where n is unknown. They have asked us to calculate KB, KM, and C. So we will not go into detail of B and C. For now, we will just concern with KB, KM, and C. C is the ratio of KB and K1, KB and KM. So starting with calculation of first term, which is KM. In this problem, luckily, as the pressure vessel is made of cast iron, both the this upper material and this lower material, both are made of the same material. So we can just use this equation. This expression is simple form of the equation for calculating the stiffness of part 1 and part 2. But when both of the parts are made of same material, we can use directly this equation. For this equation, you can just turn your page for table. Let me check the number of table. It is table 8-8. You can just check the detail of table 8-8 for cast iron material. You can check the value of E. You can check value of B. You can check value of A, but we don't know L and these two are to be calculated. D is this 5 by 8 inch bolt, so we have value of D as well. So only unknown for us is L. L is grip. In yesterday summary on slide 24, I still remember the number of slide. When I was talking about L, I was repeatedly saying lead. It was not lead, it was grip. So that was my mistake. So L is grip in this case. So we need to calculate L. Once we know value of L, we can calculate value of Km. So this is all known. We just need to calculate L. Similarly, to calculate KB, we have this equation. This equation can be seen from, you can just go into book and see table 8-7. All the detail is given regarding calculation of KB. For KB, if we go to table 8.7, we need AD. AD is simply pi by 4 D square. We know D. We know D. We can calculate AD. This AD is equal to pi by 4 into simply AD. For AD, you can go to table 8-2 for 5 by 8 inch 11 UNC threads. You can check what is the value of AT. So AT you can check from there. The value that I have found, a value of AT for 11 threads per inch is I will just write values separately here. I think it is better space. Better value of AT is equal to 0.226 inch square. Also, I missed one. No, that's okay. That's okay. I'm fine. Now we have value of 80. We have AD. Bolts are made of steel. For steel, we know it is 29 mega psi. E is 29 mega psi. Let me check again the value. I want to make sure that values are correct. It is 30 into 10 raised to power 6 psi or 30 mega psi. Value of E. You can check value of E from table 8-8. Value of LT and LD are required, and also value of L. So we know we want to calculate value of L. This is grip. Value of LT, value threaded portion in the grip, and LD, unthreaded portion in the grip. So first of all, we need to check what is the total length of bolt. Total length of bolt, you can just see that length of bolt is given here to 1/4 inch. So we have L, total length of bolt. L is known, which is equal to 1/4 inch. And for grip, we have 3/4 inch plus 3/4 inch. Grip is directly given. 3/4 plus 3/4, it is 1.5. Just because I don't have calculator, I need to just check what I have written for the value of grip. I think it is 1.5 inch. So grip L is equal to 1.5 inch. So you can just substitute this 1.5 inch here. We have all the other values, so we can just calculate the final value of Km can be calculated and is written here, which is equal to, I don't know why it is making a horizontal line. I have tried a lot. When I'm not recording the video, it never happens. But when I start recording the video, it makes horizontal lines. That's an issue. I cannot do anything. So value of Km calculated from this first equation. This equation comes out to be 8.95 mega pound foot per inch. So 8.95 mega lbf per inch. So we have Km, we have length, and also for equation we have again in table 8-7 we have length of threaded region of the bolt L T. Again, we have two equations for bolt length less than 6 and greater than 6. This is 2.25, which is less than 6. So we will use that equation, which gives LT equal to 2D plus 1/4. So LT equal to 2D plus 1/4. D is 5/8 inch. 1/4, just adding all the value, you will get length of thread region equal to 1.5 inch. So length of threaded region is 1.5 inch, total length is 2.25. So length of unthreaded region, which is equal to LD, that comes out to be 0.75. We have total length, we have length of unthreaded region, we have grip. So length of length of threaded region with the grip will be equal to 1.5 minus 0.75 will give us the value of again 0.75. So this will the value 0.75 inch. Don't forget to write units. We have all the values. Substitute all values here. For 80, just go to table 8.2. We have calculated 80. We have AD, all the values. We can calculate KB. We have KM. We have KB. So by using the equation, we can just calculate. We can just write what is the value of C. C comes out to be from KB and KM. Final value of C is 0.368 in rate. 0.368. This is the value of C. What does it show? C is the ratio of load supported by bolt and members. 36.8% of external load is supported by bolt, and remaining almost 73.2% external load is supported by members. This is the end of part 1. We have calculated KB, KM and KV. See. Now I will just pause the video and clean up the mess and resume the video again. So I have just completed my mess, clear my mess. The value of KM, KB and C are written here. In the second part, they have asked us to find the number of bolts required for the load factor of 2, where the bolt may reuse when the joint is taken apart. So what is the hint here? Bolts can be reused. If we see the equation for reload, factor of safety, NL is factor of safety for overloading is equal to SP80 minus FI divided by CP. What is SP? SP is the strength of bolt, which can be checked according to grade 5 bolt. Just go to table. There are 3 tables: 8-9, 10 and 11. Table 8-9 for this grade 8, if grade 5 bolt, just go to table 8-9. There you can see for grade 5 table, SP is given as 85 kpsi. So SP is equal to 85 kpsi from table 8-9. We have value of SP. For 80, the value is already calculated. In the last slide, I have already written that the value of 80 was 0.226 inch square. So we have 80, we have SP. For FI, we have this term, reused. So if it can be reused, the value of FI is equal to 0.75 of FP. And this is proof force, and proof force is equal to ATSP, which is this term. So this value can be calculated. We have value of AT, we have value of SP, we have 0.5, we have C, and P can be calculated. Here we know also, I have already told you that P of one bolt is equal to total P, which is 36,000, divided by number of bolt. Here we don't know number of bolt, but we know that it will be N. So use this term in this instead of P. So only unknown will be NL is given in the part which is equal to 2. So only unknown will be N. So substitute all values in the equation and calculate N. The N comes out to be, after substituting all values in this equation, value of N comes out to be equal to 5.52. 5.52. So to support this load, we have to use 5.52 bolts. But we can never use 5.52. We can either use 5 bolts or 6 bolts. For 5 bolts, the factor will be increased. So we can just say that the final number of bolts that we'll use will be 6. So we have calculated number of bolts. For this load, we have to use 6 bolts. Once we have 6 bolts, we can recalculate NL. What is this overload factor? We can calculate it by again substituting all values in here, and value of P can be calculated by 3600 divided by 6 which will be equal to 6000. Value of P will be 6000. Substitute all value here and we will get the final overload value, which has to be more than 2. So when we substitute SP, AT, FI, value of FI divided by C, which is here, and P, which is equal to 6000, substitute all values here, the value of NL that comes out to be 2.178, which is more than 2. Our required value was at least 2. In the third part, they have just asked to recalculate values, overload factor that we have already calculated here, 2.178, and yielding factor of safety and load factor for joint separation. We have the equation for value of NP, which is yielding factor of safety. We have value of SP. For this, we have all the values. SP is known, AT is known, C is known, P is known, and FI. All the values are known. Just substitute the value and you will get the final value equal to 1.16 value of this factor of safety. And for the last, which is overload for joint separation, we have N naught. This value less than 1 means that preload is less than load supported by members, or joint has been separated. So this value has to be more than 1, otherwise the joint is not safe. These two values are related to bolt and this value is related to joint. We have value of Fi, we have P, which is equal to, in this case, 3600 divided by 6, which gives us 6000. We have value of C, just substitute value and we will get value equal to N not equal to 3.8. So we have calculated 3.8 means the joint is well safe. So that was the example 8-4. Detail are also given in the book. Now we have another problem. In fact, we have 3 more problems before the end of this first part of my lecture. In this problem 8-29, they have asked us that for a bolted assembly with 6 bolts, so we have 6 bolts, the stiffness of each bolt is Kb is given and Km is also given. So we have value of Kb and Km. We can just calculate C. So for this case, if we calculate from Kb and Km, C comes out to be, I'm not writing a lot because of these horizontal line. The value of C is equal to Kb divided by Kb plus Km, which comes out to be 0. An external load of 80 kip is applied. So we have 80 kip external load and we have 6 bolt. So for 1 bolt, we can just calculate load if you want. P can be calculated, which is equal to 80 divided by, this is for load on 1 single bolt. Assume the load quality equally distributes to all bolts. So load is equally distributed, so force on 1 bolt is correctly written as P, 80 by 6, which comes out with something 13.33, I think. Also, half inch 13 UNC grade 8 bolt. So we know the die of bolt, we know threads per inch, and we know the grade of bolt. So we know all the required data. With rolled threads, we are not concerned. Assume the bolt is preloaded to 75% of proof load. So Fi is equal to 0.75 of preload, which is equal to 80 and SP. For SP, grade 8 bolt, go to table. Table number I have not written here. 8-9, 10 or 11. You can see value of SP from there, which is given as 120 kpsi, and value of 80 for half inch bolt. Value of 80 can be seen from table, which comes out to be 0.1419 inch square. So we have all the values. We can calculate Fi. So Fi comes out to be 12.77. Fi in this case equal to 12.77 K. These are the known values for this specific problem. Now what they have asked? They have asked us to determine the yielding factor of safety. This is the equation for yielding factor of safety. What is known? We have SP, which is 120 kpsi. We have 80, which is equal to 0.1419. Sorry. We have value of CP, value of C is here, value of C is here, P is calculated 80 by 6 and Fi is calculated here. So we have all the value, we can just calculate NP. Substituting all values here, the NP comes out to be 1.103. For the second part, they have asked us to calculate overloading factor of safety. We have the equation for overloading factor of safety. All the terms are same. The only difference is that this NL is only multiplied by CP, not FI. So we have all the parameters. Just calculate overloading factor of safety. And if we calculate this, substituting value, it comes out to be 1.597. And third part is to calculate joint separation. Joint separation, again, this not and not less than 1 means joint has not been completely joined, or the load is external load is more than preload, or joint has been separated. So this value has to be at least equal to 1 or more than 1. If you substitute all value, we have value of Fi, we have P, we have value of C. So substituting value, we have n not equal to 1 point, sorry, 1.1974. So these are the answers for this specific problem. Next problem is related to 829. So we have some value that we'll be using from this problem. So these are final answers are written here as well. I forgot here. For the problem 830, they have started from stating that for the bolted assembly of problem 829, so we will be using the data is all the data is same. It is desired to find the range torque that a mechanic can apply. So we are concerned with torque that is needed to apply for preloading. But how much is the preload? Preload is, if you go to see part A, they have told us that determine the maximum bolt preload that can be applied without exceeding proof length. So we will assume that Fi equal to Fp, not 75%, total Fp. No, not this equation. So we'll be using equation Fi equal to Fp. In the previous, in 829 problem, it was equal to 0.75 Fp, but this time it is equal to Fp. So the values comes, Sp is given. We know all value of Sp, we know value of AT from the previous problem. So if you substitute value, it comes out with 17.03 kip. We have Fi. In the second part, they said that determine the maximum bolt preload that can be applied while avoiding joint separation. Now we have to calculate another value of Fi, which is to avoid joint separation. This is the equation for joint separation. Just to avoid joint separation, this value has to be minimum equal to 1. If we substitute this value if equal to 1, we will get minimum amount of Fi required for joint separation. So in the previous problem, we have already value of C, we have the value of P, we have all the values, we can calculate Fi. This is the minimum amount of Fi required. So Fi comes out to be 10.664. Unit is kip. We have Fi for this, we have Fi for maximum value of Fi. In the third part, they said that determine the value of torque in unit lbf. So we need to calculate this torque. This torque needs to be calculated. K is given. And D is already given in 829, which was equal to half inch. Fi. Which value of Fi we need to use? This value 17.03 or 10.64. Just read the statement. They said that if the desired preload to the midpoint of the value found in part A and B. Part A value is 17.03, part B value is 10.664. So midway value is average of this and this. So average of final Fi equal to 10.664 plus 17.03 divided by 2. This gives us a value of Fi equal to 13.85. Unit is K. We know the value of Fi, we know D, we know K. If we substitute all the values, we will get a value of torque, and this will be the external torque required to attain this preload. And this torque comes out to be, value of T comes out to be 115.4 lbf. Value is multiplied with 12 to get value in feet. So this is the second problem. Last problem to complete this topic of fasteners. In this problem, you can read the statement. For the bolted assembly with 8 bolts, so we have number of bolts. For each bolt, KB is given and KM is given. If we know KB and KM, we can say that we can calculate value of C. For in this case, value of C directly comes out to be 0.2778. Value of C is already given. The joint is subjected to occasional disassembly. So joint is subjected to occasional disassembly. It means that maximum preload that can be applied is 0.75 SPA. And for SP, we know the value of class 5.8 volt. Just check the table 8-11 for class 8 5.8 volt. SP is given in table 8-11, which is 380 MPa. Similarly, M6 bolt, for M6 bolt, check the value of 80. It will be in table 8-1 because it is in millimeter. 8 is equal to 20.1 mm square. We get value of Fi, which is equal to 5728 5 Newton. So we can just calculate value of Fi. And what they have asked, determine the maximum external load Pmax that can be applied to entire joint without exceeding the proof strength of the bolt. So for that, we have this equation. We have value of SP. It should not be exceeded, but so we have to use NP equal to 1. SP is given, AP given, C is calculated here. Value of P is because we have value of P needs to be calculated, sorry. And Fi is calculated here. So we have all the values. If we substitute values, we get P is equal to, from this equation, we get value of P, which comes out to be 6874 Newton. This is the load on one single bolt, and for this assembly we have 8 bolts. So P total can be calculated by multiplying this term with 8. 8 multiplied by P gives us value of 55 kilonewton of external load can be supported by this 8 bolt bolted assembly. Now, in the part B, they have not talked about proof strength of bolt. Now they are talking about joint separation. So joint separation, we have another N node equation, factor of safety for joint separation. If n not equal to 1, joint is intact, and if n not is equal to more, it is safe. If n not is less than 1, it is not safe. So without causing the member to separate, so we need a minimum value of p. So n naught, we keep n naught equal to 1. Fi will come equal to p into 1 minus c. We have the value of Fi, which is given here. We have the value of c, which is given here. So we can calculate p. From this term, p comes out to be 7.932 kilonewton, and total load total equal to 63.46, multiplying it with 8. So this is the maximum load. At this load joint will be separated. Fi is fixed, it cannot be changed. When load exceed to a value of 55 kilonewton, at that point proof bolt reaches to its proof strength. And again, if we are increasing, that we also already know that bolt will never fail during operation. So at this point we can apply more load, but if we apply load greater than 55 kilonewton up to 63.46 kilonewton, at this point joint will be separated. Bolt will not fail, but joint will be separated. So the maximum load that can be applied is 55 kilonewton before proof strength, and maximum load for joint separation is 63.46 kilonewton. That is all with the three problems and one example that I needed to solve in the first part. In the second part of the video, I will explain you something about shear loading. So see you in the second video.